Hello, friend. Once again, I welcome you to another episode of Questions and Answers with Daniel Hayford. Today, we want to attempt about 82 questions. The questions span the area of chemistry of life, or biological chemistry, or you can even call it biochemistry, and then some aspects of cell biology, some aspect of ecology, or some aspect of evolution. Yes, so it is good for you if you are a biology student or a biological science student, a public health student, human biology student, chemistry student who is interested in chemistry of life, early biochemistry students, and nursing or let's say laboratory technology students. A midwife may also be interested in the chemistry of life or the basic chemistry of life. So let us see um, how we can fare with these questions. In actual fact, irrespective of your background, I have indicated that some knowledge in basic chemistry of life or chemistry of life or biological chemistry will be useful to you. Okay. Again, the last time I indicated that we must always read instruction before we attempt to solve a question. And then again, the question, we must also understand it very well so that we do not make mistake. So let's begin our section A of our exploration today by reading the instruction. The instruction is simple. It says that for questions 1 to 20, choose the best answer. Then into bracket S. Sometimes if you are under pressure or if you are the type who do not pay attention to details, you will not see the S. And so you may not know that some of the options may be, it is possible that for some of the questions, 2 or more options may be the best answers that you are supposed to choose. And so let's take notes of things like this when we are answering questions in examinations hall, whether it is middle semester exams, quiz, graduate record examination, or whatever examination that we may write as part of our exploration of knowledge or as we try to climb the academic ladder. Now, let's begin. The first question says, or is asking, it says, which of the following is one of the 4 major organic molecules which are found in human beings and other living organisms? Okay, so from this question, we gather that there are 4 major, there are 4 major organic molecules which are found in living organisms, including human beings. So to be able to answer this question, you should know the 4 major organic molecules. What are they? The 4 major organic molecules are carbohydrates, lipids, nucleic acids, and proteins. Carbohydrates, lipids, nucleic acids, and proteins. And so when we look at our options, the first option is amino acid, the second one is carbonic acid, the third or the C says nucleic acid, and then the D is sulfuric acid. So you realize that this should be our answer, nucleic acid. So nucleic acid, carbohydrates, lipids, and proteins are the 4 major organic molecules which are found in living organisms. What about the amino acid? The amino acid we know is the smallest unit of proteins. Okay, and then the carbonic acid, when we were exploring the basic chemistry of life, we realized that it is useful when it comes to the pH. Your body regulates your pH so that you don't suffer acidosis or alkalosis, and it does so because, or it's able to do that because naturally you have carbonic acid in your body and it's a weak acid. Okay, and then the carbonic acid keeps dissociating, okay, in your body, and as it does so, it releases bicarbonate. So it means you have carbonic acid and bicarbonate ions in your body, and they play a significant role in regulating the pH of your blood. Okay, and then the sulfuric acid, it's also an acid, but it's not really part of the four major organic molecules. So our best answer is nucleic acid. Now the next question is asking us something. It says 6 elements which make up more than 94% of the body weight of living organisms, including human beings, are okay. So it means the word including was omitted. Yes, this is the situation where an invigilator will come around and say that there's a correction to be made, and then the word including may be introduced. So I've done it already. So let's read our question again. So 6 elements which make up more than 94% of the body weight of living organisms, including human beings, are okay. If you've sat in any basic chemistry of life class, you realize that there's an acronym which goes like CHNOPS. Okay, and maybe some may decide to pronounce this one NOPS. All right, NOPS, NOPS, and the C is for carbon, H is for hydrogen, N is for nitrogen, the O is for oxygen, P for phosphorus, and S for sulfur. So it means that the 6 elements should be these ones. And so when we look at our options, the first one contains boron. It's not part of the CHNOPS, right? The second one contains silicon, which is also not part of the CHNOPS. The S here is not silicon, it's sulfur. And then again, the option C contains carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Yes, this is our best answer. Okay, so if that is our best answer, then what about this? It is not, because it contains sodium and aluminium, which are really not part of the acronym CHNOPS. Okay, CHNOPS. And so our best answer is this one. Yes, you that I'm speaking to right now, your body weight, okay, is made up of basically 6 chemical elements. Let's say about 95 or 96%. Some sources, I think the old ones talk about 95%, and the more recent ones we see 96. Okay, but so at least we can say that those 6 elements make, let's say, 95 to about 96%, or they can make up to about 96% of your body weight. In other words, you are basically a chemistry, you are basically made up of chemical elements, but not you alone. Remember, it is said that all matter is composed of chemical elements. All matter is composed of chemical elements, and that is irrespective of whether the matter in question is living or non-living. And for those of you who are biological scientists, when you are looking at differences between living and non-living things, one of the key things that you talk about is the fact that both living and non-living things are made up of chemical elements. Yes, and among the chemical elements, these 6 constitute up to, let's say, 96% of the body weight of living things. So the CHNOPS carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur are the 6 elements which constitutes more than 94% of the body weight of living things, including human being, you that I'm talking to right now. Remember, if both living and non-living things contain chemical elements or are made up of chemical elements, then you know they will obey the same laws of chemistry and physics which govern everything else in the universe or everything in the universe. Okay, so living things are subjected to the same laws as non-living things. And those laws are chemistry and physics, laws of chemistry and physics. So you can Google right now and probably search for the laws of chemistry and the laws of physics which governs everything in the world or in the universe. You realize that living organisms are also subject to those laws. Now we have another question, which is number 3. The question 3 expect us to be able to complete a sentence. So, and then that sentence actually is supposed to be a definition of what constitutes isotopes. So it goes like this: isotopes are atoms which have the same atomic number. In other words, if you don't know what an isotope is or what are isotopes, you won't be able to answer this question. So the first question is that I need to ask and probably answer to help us answer this question is, what are isotopes? Remember, the word isotopes comes from 2 root words. Okay, they are Greek. Okay, one is isos, I-S-O-S, isos, and it means equal. And then the other one is topos, T-O-P-O-S, which means place. So isotopes are atoms of the same elements which differ in the number of neutrons. Isotopes are atoms of the same elements which differ in the number of neutrons. Again, we can afford to say that isotopes have the same number of protons, but they differ in atomic masses, or they have different atomic masses. And the most common isotope that we know of or we talk about are the ones for the element carbon. Carbon as an element has 3 common isotopes. They are carbon 12, carbon 13, and carbon 14. Take note of the fact that we refer to the isotopes by their atomic masses. So by saying carbon 12, it means that's atomic mass of 12. When we say carbon 13, it has atomic mass of 13. And when we say carbon 14, it has atomic mass of 14. In other words, you could see that the atomic masses are different. Okay, carbon 12, carbon 13, and carbon 14, different atomic masses. Now, each of this has an atomic number of 6. And that is why the question is saying that they have the same atomic number. Okay, they have the same atomic number. And that is why our definition, for example, also indicated that they have the same number of protons, because basically the atomic number is the same as the number of protons. And so if their atomic masses are different, what constitutes that, or what brings about that one? The difference is because of the number of neutrons. For example, when we take the carbon 12, okay, it has an atomic number of 6, just like the rest. And so when we take the 6 from the 12, we get 6, and that 6 will be the number of neutrons. Now, when we take carbon 13, okay, it has atomic number of 6. When we take 6 from 13, we get 7. when we take carbon 14, it has atomic number 6. And so when we take the 6 from 14, we get 8. In other words, the number of neutrons becomes 8. So it means that for carbon 12, 13, and 14, the neutron numbers are 6, 7, and 8. So we can see that the first option is not our best answer because it is saying that the atomic mass is the same. Okay, atomic mass is the same, but the atomic masses in isotopes are not the same. So they don't have the same atomic masses. And then again, the option B is also saying the atomic masses, okay, they have the same atomic masses. So that one also makes it wrong. It's not a correct option. Now the option C is saying that they have the same atomic number but different mass, different atomic masses. Okay, different atomic masses. This part is correct, but it's saying that although the number of neutrons remain the same, but from the explanation I just did, you realize that when you take carbon 12, 13, and 14, they have neutron numbers 6, 7, and 8. So the neutron numbers are different. And so this option 2 is not correct. So which one is the correct option? The correct option may be the last one, but we need to examine it first. Okay, because sometimes in an examination, if the correct answer is not there, and you have the opportunity to write, you can write your own correct answer. So we don't have to jump into conclusion that the D is the answer by all means. So we have to examine it and see. The D is saying that the isotopes have different atomic masses, and that one is correct. And it's explaining that they have different atomic masses because the number of neutrons differ. That one too is correct. So it means our definition of isotopes is that isotopes are atoms which have the same atomic number, okay, but different atomic masses because the number of neutrons differ. So this should be our best answer for this question. Now, question number 4. Question number 4. The question number 4 is asking, it says, radioactive isotopes are useful in which of the following? Okay. So in other words, which of the options here indicates the usefulness of radioactive isotopes? The first option is saying that they are useful in dating old objects. The second option is saying that they are useful in imaging body organs through X-rays. The third option is that they are useful in imaging body tissues through X-rays. And the fourth is saying that they are useful in killing cancer cells. In actual fact, all these options are correct. And so we'll remember the instruction which says that we should choose the best answer or the answers. So this one is correct. Okay, radioactive isotopes are useful in dating old objects. Okay, and then again, they are useful in imaging body organs through X-rays. They are useful in imaging body tissues through X-rays. And then again, they are useful in killing cancer cells. So all the options are correct. You know, it is possible that you or your relative or a friend, somebody that you know, must have visited a health facility, and then the person probably have undergone X-ray test, or the person has undergone some form of X-ray activity in a health facility. You know, sometimes the medical doctors or the nurses or your care providers will ask you to go and bring, let's say, chest X-ray, for example. I remember when I had an accident, my leg bone got broken. We call it fracture. You know, I had a fracture. How did they manage to know? They got to know it when they took an X-ray of my leg, and then they realized that there was a fracture. Okay, so radioactive isotopes are useful in imaging body organs or tissues, through X-rays. And then again, they are useful in killing cancer cells. Yes. Anyway, radioactive isotopes at a certain level can actually cause cancer cells. Okay, they can be carcinogenic, but at the same time, they can also be used in treating cancer by way of killing cancerous cells. And when it comes to dating old objects, we also use that. We call something carbon dating. Okay, so we can use radioactive isotopes to determine the age of old objects. Remember the mummies, for example, in Egypt. The dating is done using radioisotopes, or let's say carbon dating. Or sometimes they find some objects. Recently, they realized that some worms which were preserved, okay, so many years ago, I think 46,000 or so years ago, were defrosted, okay, and then they wiggled back to life. How did they manage to know that the organisms were, preserved 46,000 years ago? They use carbon dating to tell what happened. We use the same thing to also tell probably when some civilizations that we find through archaeological activities, okay, maybe digging or things like that, when we find artifacts or certain things like that, we are able to use carbon dating to tell when those people lived. Then question number 5 is asking again about isotopes. It says, isotopes are atoms of the same element which vary in the number of neutrons and so differ in. Okay, so now we know that isotopes are atoms of the same element, okay, and that they vary in number of neutrons, and therefore they vary in what again? Okay, the A is saying that they vary in atomic masses, the B atomic numbers, C electron numbers, and then D proton numbers. Okay, but we know that isotopes have the same atomic number, they have the same proton number. Okay, and what is different here, okay, that we know from the previous question, is that they have different atomic masses, so we won't spend much time here. Now, question number 6, which of the following is or are true about radioactive isotopes? Okay, so it means there are so many questions about radioactive isotopes. So which of the following is or are true? In other words, this question is telling you directly that some of the options, maybe one or more options, okay, may be true. So you have to be able to tell which ones are true. The first one is saying that radioactive isotopes can be helpful to human beings. Is it true? Yes, from what we said when we were tackling this question, you can afford, okay, when we were tackling the question 4, we said certain things that indicate that radioactive isotopes can be helpful to human beings because we can use them to date objects, to make images of, let's say, organs or tissues, and we can also use them to kill cancer cells. So that's one indicates that they are helpful. Again, the option B is saying that radioactive isotopes can be harmful to human beings. Yes, I just indicated that at a certain level they can be carcinogenic. They can cause cancer. in human beings. Then the option C is saying that radioactive isotopes can damage cells. Yeah, of course, if they can cause cancer, for example, it means they can cause harm, damage to cells. So yes, they can damage cells. Radioactive isotopes can damage DNA. Yes, they can really damage DNA. This one too is true. Radioactive isotopes can cause cancer. Yes, I just indicated that one. So it means that for this question, all the options that we've seen so far are correct. So it means from the option A to E are all true. And you are supposed to choose all of them because the question is asking you which is or are. And then again, the instructions is you should choose the best answer or answers. Then question number 7. Now question number 7. Let me read it. It says substances which take up hydrogen atoms or release hydrogen ions are called. Okay, so substances which take up hydrogen atoms or release hydrogen ions are called. Then the first option is acidic bases. The second one is acid. Third one is bases. D is basic acid, and then E is salt. How will we be able to answer this question? We can try it by defining what an acid is and what a base is, or what are acids and what are bases. Okay, at a certain level, let's say the A level or the SHS level, you realize that an acid is actually a proton donor. So an acid will release proton or hydrogen ion, and then a base accepts hydrogen ion. Okay. Again, we know that bases, okay, are able to actually take up the hydrogen atoms because they accept hydrogen. And then again they release hydrogen ion. So our best option here should be C. Substances which take up hydrogen atoms or release hydrogen ions are called bases. And then the other ones that actually give out hydrogen ions, or the ones that they give hydrogen ions are acids. Acids are proton donors. So our best option is C. Now the next question, which is number 8, is asking us all these are organic molecules naturally found in human beings except, okay, yes, so it means the organic molecules have shown up again. Remember we said that the major organic molecules that we find in the body of living things, including the human beings, are carbohydrates, lipids, proteins, and then nucleic acids. Okay, so it means that the option A is an organic, or they are organic molecules. B2 are organic molecules, and then E are also organic molecules. Organochlorines are pesticides, okay, insecticides, for example, and then the same 10 organophosphates are also pesticides. So it means that in this case, we are supposed to choose C and D as our best answers. They are not organic molecules, which are naturally. In actual fact, they are synthetic chemicals. They are synthetic chemicals. And for the organochlorine, because of its persistence in the environment, it has been banned. In actual fact, we are not supposed to find organochlorines in the bodies of human beings. We are not supposed to find them in the environment, nor water bodies. Okay. Even the organophosphate too, they are synthetic chemicals that we are not supposed to find in the environment. How much more in human being? They are insecticidal, and they can also be homicidal, as in kill human beings. So the best options for question 8 should be C and D. Now, question number 9 The question number 9 is asking about carbohydrates. It says carbohydrates are made up of subunits called. Okay, so what are the subunits of carbohydrates? The options are monosaccharides, polysaccharides, oligosaccharides, and disaccharides. Okay, saccharides has to do with sugar. Okay, sugar. Then the mono has to do with one, poly many. Okay, di to oligo. Okay, more than two, but not necessarily many. So it means that our best option is the monosaccharides. They are the smallest subunits that you can find. So carbohydrates are made up of subunits called monosaccharides. One sugar, mono, one monosaccharides. While poly, many sugar, but it's not every carbohydrate that is a polysaccharide. And then again, yeah, so our best option is A. Now, question number 10. It says humans store carbohydrates in the form of what? Okay, the options are starch, glycogen, chitin, and cellulose. I don't know if you know about these, but you should know about them. You know, starch is the plant. It's normally characteristics of plants. Okay, and then cellulose is usually found in the cell walls of, let's say, plants. Okay, we normally say that plant cells are different from animal cells because they have cell wall made up of predominantly or usually cellulose. Then chitin, we normally find it in the exoskeleton of, let's say, insects, for example. So yes, our best option should be B, glycogen. That one we normally will refer to it as animal starch. And human beings are part of animals. And so humans store carbohydrates in the form of glycogen, option B. Now, what about question 11? Question 11. Lipids, which are source of energy for humans, are found as which of the following? Lipids, which are source of energy for humans, are found as which of the following? In actual fact, we have two major energy sources that we talk about. Okay, we talk about the carbohydrates, we talk about the lipids, and mostly the carbohydrates are mostly use first. Okay, if you have carbohydrates, you have lipids in your body. The carbohydrates are for immediate usage compared to the lipids. The lipids are long-term for long term. We store them and use them, you know, when the need arises. But most of the times, we do so when probably we have either made use of our carbohydrate source or depleted the carbohydrate source, or okay, so let me say that the lipids are basically the long term or for long term purpose, whilst the carbohydrates, we use the carbohydrates immediately. So the lipids, how are they found? Okay, how are they found? The first one is saying that they are found as fat and oil. The second one says glycerol. The other one is phospholipids, and the D is steroids. So which one or which of the options are correct for question 11? We can say that the option A is correct. Okay, we find the lipids as fats and oils. Fat, okay, differs or looks different from oil at normal room temperature. Fats, they are solid at room temperature, whilst oils are liquid at normal room temperature. And then again, what about the the glycerol. Okay, the glycerol is the skeleton. When you look at the chemical structure of the lipids, you see that there will be one glycerol which is linked with 3 fatty acids. And so it is more of a skeleton than probably what we are looking for. So we leave out that option. And then the phospholipids, okay, lipids, we find them as phospholipids, especially in cell membranes. And then again, we also find them as steroids. Steroids may be, let's say, cholesterol, for example, or they may be hormones like the male and female hormones, estrogen and testosterone. Okay, they are steroids and they are actually lipids. So it means our best options are fat and oils, phospholipids, and steroids. Now, question number 12. Proteins are made up of subunits called. Proteins are made up of subunits called. Also, what are the subunits of protein? The first one says amino acids. The second one says nucleic acid. The third one says folic acid. And then the D is formic acid. I think I answered this question earlier on. So simply go to the answer and say that proteins are made up of subunits called amino acids. We know nucleic acid to be one of the major organic molecules. Maybe those of you who are pregnant women, or who have been pregnant before, it is possible that you've taken some folic acids before. And then we also know formic acid. I think at the SHS level, we noticed that, or we noted that ants, for example, have formic acids in their body, so formic acid. But our best option here is amino acids or amino acids. Proteins are made up of subunits called amino acids. Now, question number 13. It says the various functions of proteins as organic molecules in the life of human beings include which of the following? All right. The various functions. So what are the functions of proteins? If you had to summarize the functions of protein using just one word, okay, each. Okay, then we'll say that proteins, what are they? Okay, the first option is saying they are hormones. The second says enzymes. The second says antibodies. The third one says they are for transport. The fourth one, metabolism. The fifth one, defense. The sixth one, supports. And then the option H, regulation. The last option, which is the option I, says that proteins are for motion. So which of these do you think is right? Which of this do you think is right? Let's take the motion. Okay, let's take the motion. Protein, as let's say muscles, for example, will definitely play some role in movement. Okay, so it is not wrong for us to say that the motion will be a function of protein. We have what we call the contractile proteins. Okay, so some of them may be what we call actin, and maybe another one may be myosin. So we can say that the contractile proteins such as actin and myosin allow part of cells to move and cause muscles to contract. Yes, the actin and myosin, they make it possible for part of cells to move, and then they also cause muscles to contract. And then we know that muscle contraction basically accounts for the movement as we see in animals. Okay, through muscular contractions, animals are able to move from place to place, or they are able to demonstrate what we call locomotion. Locomotion or locomotion. So proteins really play a role in motion. And so we can say that our option I is a function of protein. Okay. In actual fact, it has been indicated by some authorities that all cells have proteins which allow cell components to move from place to place, and that without those proteins, cells will not be able to function. Okay, yes. So it means that motion is a unique or one of the functions of proteins. What about regulations? What about regulations? Proteins are for regulation, and then in what way do proteins function in terms of regulation, or play a role in regulation, and what do they regulate? Okay, when we take hormones, for example, so look at the option A, hormones. It is said that hormones are regulatory proteins. So a hormone can be viewed as a regulatory protein. Of course, not every hormone which is a protein. Remember, we talk about the steroids. The steroids, the testosterone, the estrogen. We indicated that they are steroids, and steroids are lipids. Okay, but we have proteins which are hormones, and those ones we refer to them as regulatory proteins. And what do they do? They actually play a role in intercellular messengers, or they serve like a messaging. Okay, so they function as intercellular messengers which influence the metabolism of cells. So proteins may be or may play a role in regulation, and in doing so, they function or they serve as intercellular messengers which influence the metabolism of cells. Now think of a certain hormone that we call insulin. What does it do? The hormone insulin, we know, regulates the content of glucose in the blood of human beings and in cells. Okay, and then again, we also know of the presence of growth hormones in the body of human beings, which actually determine the height of an individual. Okay, so yes, we can say that proteins play a role in regulation. Okay, probably as growth hormones. Okay, or as hormones such as, let's say, insulin, which will help in managing the glucose in the blood or in cells. And then again, they can also serve as intercellular messengers which influence metabolism of cells. Then what about enzymes? What about enzymatic reaction and things like that? Yes, proteins really play a role in metabolism. So we can afford to say that as enzymes, okay, proteins bring, let's say, reactant together, and by so doing, they speed up chemical reaction or reactions in cells. Okay, as enzymes, proteins bring reactant together, and by so doing, they speed up chemical reactions in cells. They are specific for one particular type of reaction and can function at body temperature. So we say that proteins are enzymes. Proteins are enzymes, and they play enzymatic role. They play role in metabolism. Oh, okay, so metabolism is also an option here. So it means that metabolism is something that is done by proteins. But what about antibodies? Antibodies. Yes, proteins uh, play role in defense, and they are able to do that because antibodies are actually proteins. Antibodies are proteins, and they combine with foreign substances that we call the antigens. Okay, and when they do that, they prevent antigens from destroying cells and then upsetting homeostasis. I hope you remember what homeostasis is. Homeostasis is actually about maintenance of internal, let's say, constant internal environment through self-regulating mechanisms. And by playing a role in defense, okay, as antibodies, what proteins do is that they prevent antigens from destroying cells and upsetting homeostasis. And then again, what about transports? What about transports? What about transports? We know about channel and carrier proteins. Okay, we know about what we call channel and carrier proteins, and they are found in the plasma membrane or cell membrane. What do? They allow substances to enter and exit cells. Yes, they allow substances to enter and exit cells. And then again, we know of some other proteins which actually transport molecules in the blood of, let's say, human beings and other animals. For example, we can think of a protein called hemoglobin. Hemoglobin. It's actually a complex protein. And what it does is that it helps in transport of oxygen. Okay, so it means protein play a role. When you breathe in air, the hemoglobin will combine with the oxygen in the air to form oxyhemoglobin. And by so doing, the oxygen can be transported to all the parts of your body where you really need oxygen. And that function, we can refer to it as transport function of protein. I've already talked about the antibodies and how they help with defense. Antibodies and how they help with defense. But what about the support? What about the support? Do proteins play any role in support? Okay. In actual fact, that one too, we can say it's a function of protein. Why would we say that one? We know of the fact that some proteins have what we call structural function. Okay, some proteins have what you call a structural function. An example of that one is the protein called keratin. Keratin. The keratin actually makes up hair and nails. Okay, so your hair contains keratin, your nails contain keratin, and that is one way that we can say that your protein or some of your proteins have structural function. Again, we also know of something called collagen. Collagen. Okay, the collagens do lend support to ligaments, to tendons, and the skin. Okay, so it means that some proteins have a structural function. The keratin makes up the nails and the hair, and then collagen will lend support to your skin, your tendons, and your ligaments. It means that all the options that we have, are functions of proteins as organic molecules in the life of human beings. So let's move on to question number 14. Question number 14. Today, the teacher is going a bit slower compared to the previous episode. Question number 14 reads like this: when proteins denature, when protein denatures, its shape changes, and that situation leads to which of the following? Denaturation. Proteins can suffer what we call denaturation, and when denaturation occurs, what happens? The option A is saying that there's loss of the function of the protein. The option B is saying that there's an enhancement of the function of the protein. Option C is saying that there's replacement of the function of the proteins. And then the option D is saying none of the above. All right. The best answer is loss of the function of proteins. Why? Because the shape of the protein is very important when it comes to its function or its role. The shape is very important, and proteins really have different or shape on a natural structures. The structure could be primary structure, it could be secondary structure, or it could be tertiary structure. Okay, and even quaternary structure. Okay, so it means you can find protein as either being primary, secondary, tertiary, or quaternary structures. The truth is that all proteins really possess a primary structure. Okay, all proteins have a primary structure. When we look at the fibrous and globular proteins, for example, we see they have secondary structure. They are either helixes, like we see in the keratin and collagen, okay, for example, or they may be pleated sheets, like we can find in the case of silk. Then we also have the globular proteins to talk about. They always have tertiary structure. Globular proteins always have a tertiary structure, and most have also quaternary structure. So think of the hemoglobin, and then the enzymes, like let's say RNAs, for example, they have the quaternary structures. So when the structure of the protein is disrupted, the function will be ruined because the structure of a protein is linked with the function of the protein is linked with the structure. And so our best option is the option A. When protein denatures, its shape changes, and that situation leads to loss of the function of the protein. Now, option 15. Question 15 rather, not option 15. Question 15 says, high levels of saturated fats can lead to by increasing the cholesterol which the body makes. Okay, so high levels of saturated fats can lead to by increasing the cholesterol which the body makes. The option A is atherosclerosis. The option B is multiple sclerosis. Option C is atherosclerosis, and then the D is amyotrophic lateral sclerosis. Okay, so we see sclerosis. Okay, the question is, what is the difference between multiple sclerosis and amyotrophic lateral sclerosis? Okay, or what is sclerosis in the first place? I think that should be your assignment. Try and make some research to know. But for us today, okay, we'll say that when there's high level of saturated fat, it can lead to atherosclerosis, okay, or arteriosclerosis, and they are basically about blocking of blood vessels, blockage of blood vessels. But you can also look out for the other sclerosis that are indicated in option B and D. Option B and D. The number 16, the question number 16, the obstruction of blood vessels due to high cholesterol is a medical condition referred to as. Okay, so from here, we can afford to say that our best option should be B and C. B and C, athero and arterial sclerosis. So it means that, and this one is actually a lifestyle medical condition. So it is something that just by changing our lifestyle, we can help in managing it. And I really do encourage you to read more about it. Or if you've probably sat in my basic chemistry class, it is possible that you already know what to do. And thankfully, I know you will do it. So let's go to question number 17. Fatty acids which contain one or more double covalent bond between carbons of fatty acids are referred to as. Okay. Let me take it again. Fatty acids which contain one or more double covalent bond between carbons of fatty acids are referred to as. So the first one is hydrogenated fat. The second is saturated fatty acids. The third is unsaturated fatty acid. And the D is none of the above. Let's look at some of the things. Fatty acids which contain one or more double bonds. So we have some fatty acids that contain double bonds. And wherever there's double bond, you see that the number of hydrogen atoms will reduce. Okay, when the hydrogen are more, then the fatty acid is said to be saturated. When the hydrogens are less, then we say it is unsaturated. So our best option would be C. When there's one or more double covalent bond found between carbons of fatty acids, then the fatty acid would be unsaturated, and it is preferable. It is something that may be healthier than the saturated ones. In actual fact, hydrogenated fats are also saturated fatty acids. So in the industry, if we have fatty acids that are not saturated, okay, we can subject them to a process called hydrogenation, and then they will become hydrogenated fat. Number option 18, which of the following is true about nucleic acids? In other words, many things have been said about nucleic acids. Which one is true? The first one says that nucleic acids are made up of nucleotide subunits. The second one says that nucleic acids function in the cell to make proteins. The option C says nucleic acids include RNA and DNA. Then the D says none of the following is true about nucleic acids. Okay, so this one is supposed to be none of the above. None of the above, you know. So none of the above is true about nucleic acids. So the question is, which of this is the option A correct? Yes, nucleic acids are made up of nucleotide subunits. Nucleic acids are made up of nucleotide subunits. And then the B says nucleic acid function in the cell to make up proteins. Yes, they play a role in protein synthesis. Nucleic acids do that. And then the third one says nucleic acids include RNA and DNA. That one too is true. One is RNA and one is DNA. So deoxyribonucleic nucleic acid, deoxyribonucleic acid, and then ribonucleic acid. Okay, so one has a ribose sugar, ribose sugar, and then the other has deoxyribose. Okay, so the pentose sugar in the DNA is absent, and oxygen, whilst the oxygen is intact in the RNA. So this one is correct. Nucleic acids are made up of nucleotide subunits. Nucleic acids function in the cell to make proteins, and then nucleic acids include RNA and DNA. So those of you who are familiar with protein synthesis, probably at the SHS level, for example, or advanced level, or through the basic chemistry lecture, or the biological chemistry, chemistry of life lecture, you have realized that nucleic acids really play a role in protein synthesis. The RNA, for example, you realize that there are 3 types of RNA. Okay, one is messenger RNA, for example. We also have the transfer RNA. So, would you like to tell me the other one? You can leave that one in the comments. There are 3 types of or categories of RNA. Okay, I have made mention of the messenger and the transfer RNA. So you will have to indicate the other RNA that you know of, at the comment section. But for now, I think we should establish the fact that the nucleic acids really play a role in protein synthesis, and they include RNA and DNA. RNA and DNA. Of course, in the case of viruses, we normally say that they have RNA or DNA. But note that a virus is not considered as a living organism by all authorities. We can rather say that they are organisms at the edge of life. Viruses are organisms at the edge of life. So for question 18, the 3 options are all true about nucleic acids. Now the 19 saying that the pentose sugar in nucleic acids include, okay, the pentose sugar. I think from what I indicated here, we can go straight forward to say that they are deoxyribose and ribose. Okay. So the pentose sugar in nucleic acid include the ones that are deoxyribose and the ones that are ribose. So this one, oxygen has been eliminated, so deoxy, and then this one has that oxygen there. Then again, question number 20 says bond in which the sharing of electrons between atoms is equal is called, okay, so in some, there are some bonds, the sharing of electrons between atoms is equal, whilst others is not equal. So the ones that is equal, what is the name that we give to that one? Okay, the option A is saying basic chemical bond, B is saying hydrogen bonding, C is saying non-polar covalent bonding, and the D is saying polar covalent bonding. Okay, our best answer here should be the C, non-polar covalent bonding. So bond in which the sharing of electrons between atoms is equal is non-polar covalent bonding, and the bond in which the sharing of electrons between atoms is not equal is polar covalent bond.